I wanted to go over with you the short answer questions on quiz number 4. Let's start with question 6. All right, this question asks you, it gives you the scores for an exam. It said that the scores for an exam are normally distributed with a mean equal to 235 and a standard deviation equal to 52. It wants you to identify the scores which mark the boundary of the bottom 5%, the bottom 5%. So this one's a little bit tricky actually. It's important as always to draw out our distribution. I didn't do a very good job there, but at any rate, this is 235, and we want the bottom 5%. That's this area in here. Okay. Our table, however, is set up to give us scores in here. So, what do we need to do? Well, let me just get rid of these first. And we're interested in finding the scores instead in the top 5%. We can use the z-score that we compute for the top 5% to stand in for the bottom 5% as long as we change the sign of that z-score, which I'll describe in a moment. But at any rate, let's take a look here. We're interested in the bottom 5%. This entire area in here is equal to 0.5, or the 50th percent. The 50th percent. We want this area in here. So if we have 0.5 and we subtract 0.05, that would be this 5% area in here. That's going to give us 0.45. We go over to our z-table over here, and we look in the body of the table for the z-score closest to 0.45. And let's see, 0.4495, 0.4505. You could use either one. My calculator came up with that score over there. So we want to look from here and from here, and that's going to give us a z-score there of z is going to equal 1.64. Now again, remembering that we're interested here in the bottom 5%, number 1, and number 2, remembering that the distribution is symmetrical, we're going to, for our problem, we're going to have to use negative 1.64. And that area, even though I didn't draw it very well, that area is not about, it's exactly the same. It's exactly the same area. The top 5% area is the same as the bottom 5% area, and the z-score associated is going to be the same, except on the bottom side it'll be negative. Alright, so how do we solve the problem? Well, recall that our z-score formula is equal to x minus mu over the standard deviation. We transform that algebraically into the following. X equals sz plus mu. And if we do that bit of arithmetic, we're going to get x equals our standard deviation, which was what again? It was 52. 52 times negative 1.64. Negative 1.64, negative 1.645, plus 235, our mean, right? And that's going to give us a value of 149.46. A number of people forgot to transform that z-score to take not the reciprocal, to take the negative of that z-score, and they would have gotten a value of around 320. I gave you part credit for that because you were on the right track. You knew how to solve the problem. You knew how to find the correct z-score from the table. You just forgot that aspect of turning it around and finding the negative, so you would have gotten part credit. All right, let's take a look at problem 7. Problem 7, let's see. Based on an examination of n equals 895 cases. Drawn from the General Social Survey, you find that the mean number of hours worked last week for this group of people was 41.47 hours, and they gave you the standard deviation of 15.4. So the problem is pretty straightforward so far. We need a z-swell. Let's see what we're asked to do. The problem asks us, here's our mean, 41.47. The problem asks us to find the probability that somebody scored higher than a 60, that somebody worked more than 60 hours, that area in there. All right, so that's what we're aiming for. So in order to do that and use our z-table, we have to convert everything to a z-score. We have to convert that raw score of 60 to a z-score. So z equals 60 minus our mean, 41.47, over 15.04. I'll spare you the intermediate calculation and tell you that the z-score we're going to get is 1.232. 1.232. All right. So, again, the table is showing us this area in here. In order to get the blue shaded area, this area in here, we need to take 0.5, the total area to the right of the mean, and subtract the value that we get for this red area again in here. So let's take a look at the probability associated with 1.232. 1.23 is about as far as we're going to get. That is 37.07. So 0.5 minus 37.07, was that right? What do we have again? 1.232, 37, yeah, nope, 39. 39.07. That's right, 0.123. Okay. And that is going to give us, get out my calculator because I solved it using a distribution calculator. Let's see if we get the same answer. Minus 0.3907. Yes, we do. It's going to give us 0.1093. Let me make that 9 a little better for you. 0.1093. All right, so that's part A of the problem. That's the probability that somebody worked more than 60 hours. That's the probability that in this sample somebody worked more than 60 hours. Now, the question also asks, part 2 of the question asks, how many people is that? Well, this 0.1093 translates, of course, to 10.93%. 10.93% of the people in the sample worked more than 60 hours. So to figure out the number of people that equals, we simply take 10.93% of 895, and you'll find that that is going to equal about 97 or 98 people, depending on how you choose to deal with the fraction. The correct answer is 97.55. So I'd accept either that or that as the correct answer. I hope that that helps understand. I hope that that helps you understand those two questions.